Good day, sir. My name is Sunshine Labay from HR32. So today we're going to talk about probabilistic time estimation, a powerful technique used in project management to handle uncertainty in task duration. First, let us know what is probabilistic time estimation. Probabilistic time estimation is a project management method that uses a range of time estimates to reflect uncertainty and risk rather than relying on a single fixed duration for a task. Probabilistic time estimation is a project management technique that accounts to uncertainty in predicting how long tasks or activities will take, instead of assigning a single fixed deterministic duration to a task. It uses range of possible durations to reflect the natural variability and risk in time estimates. We have here probabilistic estimation and deterministic estimation differ mainly in how they handle uncertainty in the predictions. In summary, deterministic estimation is straightforward but often unrealistic in uncertain projects, while probabilistic estimation is more accurate for managing complex projects because it reflects real-world unpredictability. Next, we have range of estimate. Probabilistic estimation provide range such as optimistic time or base case scenario, the shortest possible time to complete a task assuming everything goes perfectly. The purpose of this optimistic is to set the lower limit of the time estimate range. Next, we have most likely time, most probable scenario. The best estimate of how long the task will usually take under normal conditions. In this time, the purpose is to represent the most realistic duration based on experience or historical data. Last is pessimistic time, worst case scenario. The longest time the task might take assuming significant problem or delay, but not complete failure. The purpose of this is also to set the upper limit of the time estimate range. These three estimates are used in the formula. Expected time, O plus 4M plus P divided 6. This formula gives weighted average, emphasizing the most likely time but also considering the uncertainty provided by the optimistic and pessimistic value. We have also expected duration, which is the Perth method. A common formula used is the program evaluation and review technique estimate. So we have here example on how to compute the Perth or the expected time. So we have activity A, B, C hanggang G. Predecessor A to F and optimistic 2 to 4, most likely and pessimistic time. So this is the formula of expected time O plus 4M plus P divided 6. And also we have variance, which is P minus 4 divided 6 times 2. So next, we proceed to compute the expected time. So now I have here I have also done arranging the expected time, which is this. So now we proceed to computation. So letter A, the optimistic is 2 and plus 4, the given number, times 4, which is the most likely, plus 6, which is the pessimistic time, and also we have 6, the given number. So now we proceed to compute this. first, all you need to do is to compute first the multiplication, which is this, before you proceed to compute everything. So 2 plus 18 plus 6 is 24, divide 6. So now, before you proceed, the expected time for the letter A is 4. Two plus 16 plus 6 equal 12. Then copy the 6 and also the 24 divide 6, which is 4. So next, 1 plus 8 plus 3 divided 6 plus 12 divided 4. Here, we're done computing the expected time, which is this. 4, 2, 5.33, 3, 2.66, 2.66, and last is 5.33. So now, we proceed to compute the variance. Is how to find the variance. So now, we need to compute all of this to find the variance. So this is the formula. So for A, you need to do first is to compute the open and close parenthesis before you compute the division and also the multiplication. So 6 is 4 minus 6, so then comes 6 is 2. Here are the variance, which is the 3, 6, 2, 6, 6, 6, and 3. So now I'm done creating network diagram, and we need to do is to arrange it and find the critical path from the diagram. So this is the activity OMP, expected time and variance. So now here use the computed expected time from each activity. So we need to get the expected time here. So the expected time of letter A is 4, letter B is 2, letter C is 5.33, letter D is 3, letter E is 2.66, F is 2.66 also, and G is 5.32. So the next one, to find the earliest, this is the earliest start and the earliest finish. So now, since the earliest start is this is the earliest start. So this is the first, this. So here, the estimated, the earliest start is from letter A is 0, since wala naman. And also the letter B. So now you need to do is then compute the earliest start from the predecessor. So 0 plus 4 is 4, and 0 plus 2 is 2. Yung letter C, since sa A siya nakatutok, so ang hanapin, earliest start niya is 4. Since wala naman siyang kadugtong. Then, ang earliest start naman dito sa letter D is kung sino yung pinakamataas na earliest finish, which is the 4. Then, compute it. 5.33 plus 4 equals 9.33. And the letter D is 4 plus 3 equals 7. So here, letter C, the letter E, the earliest start is from here, letter C. So we have 9.33. So you need to do is to compute also 9.33 plus 2.66 is equal of 11.99. Next is F. So you need to do is to find the largest number, which is 7 or 11.99. So the largest is 11.99. Small. So no. No, this is 7. is 9.66. The last one is 9.66, 14.20. So now we need to find the largest, which is 14.29. So the largest, the earliest finish is 14.29. So you need to do is to subtract. So 5.33 minus 14.99 is 6. Also here 12.33. So the smallest is 9.66. Times 7. Also here is 12.33. So minus is 7. Then here is 7 minus 4. Then 4204. So now the slack is 0 since pare-parehas naman, and this is 4. Here is 2, and this is 0, 0, slack is 0. The slack is 2. So the critical path is A, D, F, G. Since lahat naman is for 0. Now all you need to do is to find the critical path from here and circle here. So the letter A, which is 4, and letter D is 3 and 6, then letter F and G. And also you need to compute 14.89. So here is 18. So if my client expects to finish the project on or before 20 days after it has been started, so we need to do is to compute the D, which is the division minus this, the total of the expected time. So the letter D is this, the 20 days project. So Z equals 20 days minus 14.29 divide and square root of 18. So next is 5.21 days square root of 4.24. So the total is 1.18. Here. So 1.18, there is 0.8 810 probability based on a single tail normal probability distribution table. Therefore, the probability that the project can be completed in 20 days or less is 88.10%. So the percentage of is 88.10%. This is the percent which the 20 days you can start the project. So now, why use probabilistic estimation? So why with this method? Why we use this method? It helps manage uncertainty and risk. Next is it provides more realistic schedule, and it supports better decision making under a certain condition. To sum up, probabilistic time estimation is a smart way to handle the unpredictable nature of project by using a range of outcomes, especially with tools like the PERT formula. Project managers can plan with greater accuracy and confidence. Probabilistic time estimation allow us to plan with greater accuracy and confidence by acknowledging that uncertainty is a natural part of every project. Instead of relying on fixed guesses, we use a range of possible outcomes to make better risk-informed decisions. By applying tools like the PERT method and variance analysis, we're not just estimating time, we're preparing for reality. At my end, thank you, and always remember, successful project management is not about being certain, it's about being ready for uncertainty. My name is Sunshine Labay from HR 32.